An example of another loop, it still says for loop, but the content is going to look somewhat different, right? So I just clean this up. Standard string is the type of element contained within the vector, right? So although we use this demonstration here, 1, 4, 2, 3, and 5 elements here in our case are strings. We can type any text we want, and the vector will simply accumulate those strings. So we can say that for each string, str, in this vector of input of strings, simply print, I will just comment this out and replace it by str. Okay, so this is another syntax of the loop which is available, which will say for each string in this dynamic collection of strings, give me this string, make a copy of it, and then I can do whatever I want with this, and I can print it. So let's give it a test, right? We'll build this program, run it, and again, I'll just input some text, some inputs like this, and hit blank line, and you see that it creates this output. And I will show it to you in a comment, right? So this is what I just did, and this is the behavior is identical to this loop, but since the only reason to use index was to access individual elements, we can perhaps replace this code with this type of loop, and this type of loop is called a for each loop. Okay, so which is another type of loop available with collections of elements. Okay, so that's our basic coverage of convenience of having a vector, and I chose to use string to contain the elements within this vector. If I wanted to change this to let me actually very quickly give you another demo here. I will make a copy of my main function as I did before, and this one I will just simply say this was version 1. If I want to switch from using strings to using integers, I can now replace string with an int. Okay, so now I am trying to construct a vector that contains integers. Input, how about I say, well, I can say numbers, or simply say numbers, right? So I will be entering some numbers. Now my input also becomes an int, right? So I'm expecting the user to type integers. Please enter some numbers or blank to exit. Okay, so we'll see how blank works this time, but of course getLine works only with string inputs. So instead we will be using this type of input, simply formatted input, expecting integers and populating input with expected number, right? And this time, of course, input cannot be compared to a blank string, so I'll just simply get rid of this. And how about I just say Control Z, right? Control plus Z to exit. right? Because we know that Control Z closes input string, so let's keep it simple. Now, so notice that pushback syntax is exactly the same. Because if this used to be a vector of strings, it's fine. But if now we replace it with being vector of integers, and I do have an integer, my string is gone, is replaced by an integer data type, I get integer from the keyboard, and then I push it back to this now is no longer a vector of strings. This is called now numbers, right? Numbers push back another input. Likewise here, I will say you entered this many numbers, right? Changing strings to numbers. Let's just go back to the simplest version of this. Again, int value, right? Value in numbers, right? I'm just changing the names of my vectors and values, and so here we can say that you entered, and I can now print individual value like this. I'll simplify it as much as possible. So you can see that it works exactly the same way with strings if you choose vector of strings, or numbers, or pretty much any other data type that you like to try. So that's very convenient and very powerful feature. To make things more interesting, I would like to also before displaying these numbers, I would like to sort them. That can be done simply like this. Numbers begin, numbers end. So there are positions inside the vector, and the well-known positions are begin and end. And this way we can specify these two positions, begin and end, and we can sort our numbers. Now, in order to bring standard sort algorithm into the scope, we say include algorithm, right? So this is what we need to add to the list of includes in order to bring the sort function into the scope, and we can start using it. There are numerous of other algorithms, like for instance reverse or search for elements, or there's like the whole collection of algorithms. You can research what is presented within this header file, and you'll be amazed there are actually probably more than 100 of different algorithms that are available off the shelf, and you can start using them. Of course, sort is very easy to demonstrate. All right, so let's do this demonstration. I will build this. Oh, I made another mistake someplace. Yes, so I need to get rid of extra parentheses. Okay, so build it and run. And I will type some numbers like 2, 5, 9, 7, and 4, and 11, and see what this will be doing. Control Z to stop the input, and you see that I enter. So this is how it looks like if I bring it back to display for the final results of this execution. Right. So this is now this program generates output that looks like this, and you see that the numbers were sorted according to their values. Right, so this is what my input looked like, and of course my input was unsorted. Then Control Z closed input stream, right? Of course, this input stream got terminated right here, right? And we stopped adding elements to the vector of numbers, and then we sorted the numbers. So, of course, this is well expected and very convenient that we can do this type of sorting. Another thing I want to show you is that, for example, if I wanted to, just to show you very quickly, if I wanted to limit the sorting, for instance, to avoid to continue sorting, but avoid sorting the starting element. So I can do it very simply by adding, for instance, 1, right? So begin plus 1 indicates that the sorting should start not from the initial element, but from the second element from the start. So to demonstrate, if I again enter values such as 999, 222, 555, 333, and 444. Okay, and then hit Control Z. You can see the result of my output now is the result of my output changed, my input changed, and of course the output changed. You see that 999 was not sorted because I decided that the starting position of my sort should not be the initial position, but position plus 1, right? So position plus 1 avoided reorganizing sequence of elements in such a way that 999 stayed where it was, and as a result, the rest of the elements were sorted except 999. With a code like this, you have to be careful that plus 1 does not put you out of range. And by putting us out of range, I mean that the vector elements supposed to stay within the scope when we try to specify them. They're supposed to stay within the scope of the vector, within its range. So the range is really 0, 1, 2, 3, 4, 5. And if I say that I want to access element number 10, of course, I will get a memory access violation error, and it will be crashing my program. So just be aware of it. So anyway, I'm just going to get rid of it. We will have a chance to discuss this in the future, and that's a little bit of showing you what is available with vector and also with strings and algorithms. As we move along through a series of examples, we'll just go through more examples. So these are basic computational facilities that we'll be using for a while, because we still have to discover functionality of different operators, functionality of basic data types, and functionality of the language, other language constructs. So that's our intro to these basic facilities.